Welcome back. In this video I'll be solving Leetcode problem 2035, partition array into two arrays to minimize some difference. Okay, so this one was troublesome for me, but let's get into it. So we are given an integer array nums that is size, essentially it's even size, so it has 2 times n integers, and we need to partition that array into two arrays of size n with minimum absolute difference, and return that minimum absolute difference. So essentially for each number in nums, we need to decide does it belong to array 1 or array 2, and with n elements, or let's say m elements because n is used in different sense here. So with m elements, that's 2 to the m complexity time-wise, but the problem is that we have m30, so 2 times m30, which is too much. So we need to figure out something better. And something better is called man in the middle. We are not into cybersecurity, so meet in the middle. So meet in the middle. And what meet in the middle does is that it splits. It's like a general thing where you split, where you can't solve the problem of that size, but if you split the problem in two, you could solve it and you could find some way to efficiently merge it together, having lesser complexity than if we did everything on the complete input. So idea for this one would be to separate array 1, separate nums in two arrays of equal size. Find the sums, subset sums for all of them. So for all in array 1 and for all in array 2. So let's say for array 1 we would have, if it's like this, we would have 0, meaning using no elements, 3 meaning using this element, 9 meaning using this element, and 12 using 2, and the same thing for the right part. And then we would go through numbers in so left subsequent left subset, also by the, so we track the size, we know the size of the subset, and find the pair on the other side that's the best. And how can we do that? Maybe I'm explaining too much, but I'll finish and then you'll get it in the code if it's not straightforward. So this one we generate. So we have for 0, let's have like a dictionary. For the 0 it's 0, for the 1 it's values 3 and value 9, for the 2 it's 12. And for this one we'll do the same thing, but for this one we will also sort that list that corresponds to some key, so that we can do binary search on it to find the closest one to the, let's say, the best one we need to make it minimum difference. And that's essentially it. So it was a lot of talking, and let's try to get into it. So the first step would be we need to split in two. So I'll have left is equal to, let's have len of nums divided by 2. So also total will be sum of nums. This also if n is equal to 1, we just return nums of 0, nums of 1, but we need absolute value for that. Okay, that's like if this is not so, then we go sum total and we split in left and right. So left is nums from start up until n without n, and right is from n on. Okay, now we need to generate all the subset sum. I'll call it s left, will be collections dot default dict of type list. S right, the same thing. And now I need to store, or let's go for that, find all subset sums. I'll use bit masking. I was forgetting what was the term. So I will use bit masking for this. How can I use bit masking? So how does that go? I forgot it. So I think I need to check if each of these two is to be used. For, let's call it n in, for I in range, I think I'll do like this because I want to do it for both. I in range n. Okay. But this will be if I include the number. Let's make this j. I need to do for I in range 2 to the n. Is that so? So for the I in range 2 to the n. Okay, I'll need to know how many elements of the subset I use, subset I use. So let's call it count and have bin of I dot count ones. This is the number of ones used, and I want to check if I and 1 moved by j, yeah, if this is not 0, then I use cur left, cur right. So cur left, if it's not 0, plus equal left of j, and after that, so left of count I append current left, right of count I'll append current right. It is good. So I'll go for each I in range 2 to the n. Okay, and that will be 2 to the n minus 1 is the highest, so that's all ones. And I'll check how many ones I have. And I'll check if I have to add a number. So j in range n. Okay, I think this is good. Yeah, I think this should be good. So 0. This part should be good. So now I have S left and S right contain subset sums. So it's essentially a dictionary having a list of elements that so each key is the number of elements used, and value is the sums that number of elements. So the next step is to would be to find. So next step I have to go through all. So let's say that. So for yeah, I need to also sort. So sorting right for key in S right, right of key, do sort it. Dobra. Okay. Yeah, I think that's it. So we now need to find the best. The best will be absolute difference of sum of R or left right minus sum okay, that's the current best. Let's see if we can do better. So for key in left for value in left of key, I need to this is correct. So I need to find the best, and best is minimum of best, and let's call it finder, which will take we use target then. So what's a target? Yeah, it can be uneven, so I can think about it. So best is mean best in Finder, and what I'm trying to find. So I'm trying to find. I can put it also in Finder. I'm putting for sure right of n minus k. So that's for sure. And here I can put value in. I can put value in. That's it. Okay. And let's implement Finder here. What currently I have. And I have options. And I have total. So what are we trying to do in the Finder? So in the Finder we are trying to find best one from the options that will give us so let's call it target would be yeah, I could use essentially, yeah, I was thinking of if it's uneven sum, but yeah, we can use it. So target would be total divided by 2 minus current, and we have to find, let's call it idx, I think it's bisect dot bisect left options, and target is what I'm looking for. And so this will return either number that is out of range. If it finds one, it will return one that is greater than the target, or I think target, not sure, something like that. So yeah, if it returns 0, then the 0th element is the answer. If it returns any other, we need to check also one before. So that's essentially the so check if so if idx is greater or equal, or if it's equal, yeah, I think it's equal, so length of let's put it greater equal, I think length if it's greater equal and options what's all it best found, so it's best diff is equal to, let's have it best difference is currently targets, and so if idx is okay, Now I'm thinking of it. There is more than one case, so if it's 0, it is 0. If ID, let's do it like this. So if it's 0, it's 0. That's what I know. So if IDX is equal to 0, best difference, or let's go with difference. That's the target I have. So I'll need to do absolute of total minus 2 times current plus options of 0. So if it's 0, there's nothing I can do. If it's just go for a second. Timer, where can I mute? I need to mute. For a second. Just wait. Well, sorry about that. I'm back. So where are we left? I'm not sure how that IDX works. I think it always gives you one greater than. So if we get 0, we need to just, that's the only option we have because the next one is also greater. Come on, it's goddamn. Okay, so I don't need to even find the difference. I just have to return this one. Then the next one is if IDX is equal to length of n, I suppose, then n minus 1. And if this is not true both, then difference is target, and or I need to find the one that is closer to the target. So if I'll need to use either this one or one before. So let me do this. Return minimum of one absolute, other absolute. So return the minimum of absolute of what? So same thing. So total minus 2 times current options of idx and x minus 1. So this should be it. Okay, so I always return something. Best is minimum of those, and here I just return best. Let's see. Turn min. Suppose this. Come on. What's the problem? So much. It's not the fun button. So if idx is 0, I return this one. What? What? So if it's 0, if it's n. All options need to have at least 0 elements, so I missed something. I'll just check how how is bisect used. If I have it correct, so I should use something like this if it's... Whoa, I know what I did. Yeah, no word. It's all I'm a fan, not a fan, but options. Geeks -1. Yeah. So absolute total. Okay, yeah, I think I got it right this time. Oh, yeah. So, yeah, let's see if it will work. And it works. Yes. Uh, so, yeah, this one was, I wouldn't say easy. There was a lot of things to do. So, is it the hard? Yeah, it's hard. It's solid hard. So, but yeah, this bisect part. It seems I got it correct. So, yeah. Okay. Hope this was helpful. If you have any questions, leave them in comments. And thank you for following this one. See you in the next.